Hello everyone, this is a video lecture for 1314 section 3.5, rational functions. Yeah, blah blah blah, fraction functions, that's what they're trying to say. Fraction functions? Ugh, I mean look right there, that's supposed to be an equals by the way. Fraction functions, and I'm just going to tell you the format. It's technically going to be top and bottom. Top and bottom. That's how we view these things. So I'm going to say the word top. I'm going to say the word bottom. Now you know where they're coming from. It's numerator, denominator, but that's top and bottom. You know what I mean? Okay, so they say find the domain. And really all we're doing here is bottom equals 0. There's a little bit more going on behind all these. And let me just check ahead if that's okay real quick. Are we going to talk about this again later? Oh, we will. Okay. That's fine. I just wanted to look ahead. So bottom equals 0. Let's just keep it easy. So we got this guy here, x squared minus the 100, set it equal to 0. You can move the 100 over, square root both sides, and we get plus or minus 10. These are holes in your domain. If you remember, I'm doing, do we have division? And of course, if you have a fraction, you got division. Do I have a square root? I have a square, but I don't have a square root in the original. So I don't have any start points. I only have holes. I'm going to go around them. Negative infinity to negative 10. Negative 10 to 10. 10 to infinity. Now, if you notice that if you factor it, technically these will also cancel. If you did this, and then these guys cancel, leaves only this guy behind. So there's only one real hole. No, this is still the answer for your domain. Okay, this is your answer still. But there will be a distinction about what cancels and doesn't cancel here in a few minutes. Okay, so for right now, they're just talking domains. I'm just doing the workbook, guys. Just doing what they say. Can I ever have this one equal to 0? No, and I'll show you just because I'm trying to be a good teacher for a second. Can you have a square root of negative number in this class? Because what this is imaginary numbers, and we don't have that in this class. Yay! Yeah, you don't. So there's no holes, and therefore your default answer is negative infinity to positive infinity. There you go. Same thing with this one. X equals 3 is my hole, so I go around it. Negative infinity to the 3. We've already done all this back in chapter 2. I just wanted to like review this, I guess. Not me. They wanted to review this, and that's fine. So what does a rational function look like? Like these, they call it the parent functions because they're like the basic ones. I would say that typically we have like 1 over x, which looks kind of like this. It keeps going. It's, yeah. Okay. I'll fix it. There you go. Or the other one is 1 over x squared. And it looks something kind of like this. Okay, you can go to Desmos for something better. But this is what they're talking about with fraction functions. We're going to have this thing called vertical asymptotes and all this other stuff. We'll get to it in a little bit. Okay, so arrow notation. This is important for your homework, and I don't know if it's even on a test or not, but you have to do it. So here we go. This is not too bad. It has x, arrow, 1, minus sign. So this is x approaches 1 from the left. That little minus sign means from the left. Okay, so 1 is, oh, you know what? I need to change my color here. Let's go to an orange. Let's go like right there. That's a nice orange. So orange. This right here, no. That did not work. Let's go to a green, a darker green. Okay, that's a little bit better. Okay, so this is 1 right here. This is 1, and I'm on the left side or I'm on the right side of this, and I want to get really close. And I know I drew all over it, but I want to be on the left side, and I want to follow the graph. And if you look back at the original, it went back up this way, and so it goes up to positive infinity. That's your answer, positive infinity. You're done. That was it. That's the entirety of it. Let's just do another one. So let's just say I got x is approaching the -3 from the right. So notice that this little guy here means from the right. So negative 3 is right here. It's this dashed line. And again, all of this doesn't mean anything anymore. I'm saying right here I got left and right sides. And I'm going to be on the right side of it. So on the right side, see how this is going up here? So yet again, I would say this is my y value is approaching positive infinity. One more. Let's say that I have negative 3 from the left. Negative 3 from the left. Again, this is right or left. Left is this side. It's like we're looking over here. And I want to follow the graph. I follow the graph, and I'm going down this time. Negative infinity. Okay. So let me do this last one, and I'll give you a little bit of a hint here. So negative infinity is this way. So I'm going this way. What would be the y value? This f of x, this means y. So what's my y value? What's the height? It's at negative 2. I'm going this way, but what's my height? It's negative 2. And there's your answer. Same thing if you were going this way, it would be a negative 2 as well. Just whatever the height is. Okay, so is there a trick for this? A little bit. So if you got a number, if they start with a number, then your answer is probably going to be an infinity. If you start with an infinity, your answer is going to be a number. Okay, so here it's multiple choice, essentially, negative or positive. You're just looking at if they go up or down. And this guy right here, it's just going to be a number. It's always going to be the horizontal line height, whatever that is. All right, there you go. Cool. I'm just doing the workbook here. I think there's a lot better examples, and I've probably done it on other videos, but I really think that I just want to go through the workbook here. We got enough to do here by itself. Okay, and then you move on. You'll never see it again. So, okay. It says transformations. That was back from 2.5 or something like that. Let's not overcomplicate it here. It says find the graph. Oh, yeah, Desmos. So, not to be too weird here. Notice that we got something going on right here. And so I'm happy with this guy or with this guy. And this is where we have to be a little bit more cautious and understanding. This is on the outside, so we're actually going to be going down here. But this is on the inside, and so inside, what is it? Is it opposites? We're actually moving to the right, to the positive. So we're going to the right 5, but we're going down 3. See how this one's different? You have to kind of look. We went right 5 and down 3. This is the correct answer right here, okay? That's you have to be careful. Blah, 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 moving on. So vertical asymptotes, this is when the bottom is equal to 0. And we already done that earlier. We've seen it. There's your arrow notation stuff again. But I want to give you a little bit more specifics, okay? And I think that they're right here is how we're going to learn about it. There's two different options. You see, I want bottom equals 0 for sure. But there's two things that could happen. It could not cancel out, and that would be a vertical asymptote. Or it could actually just cancel out, and what you're left with is a hole. Now, both of them are holes in your domain technically, but how they're talking about it with vertical asymptotes and holes, see that language? It's either not canceled or it is canceled. So let me just show you this guy in particular so you can see it. What if I did this? I mean, you're looking at it, right? Whoop. Now, because it canceled, that doesn't... Oh, no, I don't have that answer at all. You do have the answer. It canceled. That means that this is going to be a hole. And I'll solve it here in a second. This guy did not cancel, so he's going to be a vertical asymptote, okay? So how do we put this in? So this one's super easy. It's just switch the signs. X equals -9, vertical asymptote. So -9 will go right here. This is your option. But the hole, solve for x, it's kind of weird because there's nothing there. Well, that's the point. There's nothing there. It's 0, 0. All right, cool. We did it. It's all wrong. What did I do wrong? My math lab. You need to type x equals -9. X equals 0. Oh, I know. On a test, this is so frustrating because you got the right answer, and then it says, no, you need to put x equals in the front. Womp womp. Chad, I'm Chad, hello. Chad is going to tell you right now, if that happens to you, if it's on a test and it says, oh, you got it wrong because you put an x equals, tell me so I can go back and add partial credit, because that's just not cool, you know? I mean, I get it. You got the right numbers, and you got them in the right place. You just missed an x equals. So just talk to me, and I'll go do that. Okay. This one's kind of sad because there's not really a lot of example here, but bottom equals 0, and there's no canceling or anything. You can't set it equal to 0, so there's just nothing there. It's like, wow, man, what a letdown. So let's do our own, if that's okay, for just a second. Let's say I had x minus 2 divided by x minus 2 and x plus 3. So then these guys cancel, so that would be x equals 2 as a whole. This one did not cancel, so that's x equals negative 3. Again, there's opposites there, is a vertical asymptote. Okay? So there's your answers. You type them in however they want. There you go. Cancel or not cancel. The vertical asymptotes, again, are these vertical lines that you'll never cross on your graph. And we'll be seeing those as we keep going, okay? Oh, we're doing it. Oh, there was another problem. Look. So let's factor the bottom. What two numbers multiply to make an 81 is 9 and 9. But notice that I have to have a plus and a minus. Cancel. So it's x equals a positive 9 as a whole. This guy here is a negative 9. And I want to make sure you emphasize the negative. And that's a vertical asymptote. So there's your answers. Put them in. There you go. Okay, cool. Horizontal asymptotes. So these are horizontal lines, super nifty, same kind of thing. And here is your formula for it. I'll go ahead and let you read. Did they leave space for me? They did! This is the Chad space. Chad space, because this is mush. That ain't nothing. What is this? Copy that down, huh? No, Chad space, we're going to put the real thing here. And I call this the 3 rules. So let's go through the 3 different rules for horizontal asymptotes. Rule number 1, and one last thing. I'm always referring to top and bottom, okay? Just remember that. Okay, so if the degree of the top is less than the degree of the bottom, then you have a horizontal asymptote is at y equals 0. Like, that's your answer. It's 0. I'm going to do a quick example on the side for each one of these. Let's say that my function was x squared minus x minus 1 divided by x cubed plus 100. I don't know, just whatever. I'm not looking at all this stuff. I'm looking right here at these two guys. And so my degree of the top is less than the degree of the bottom. 0, you're done. That was it. No math. So that's kind of nice, right? Rule number 2, if the degree of the top is equal to the degree of the bottom, what do I do then? Horizontal asymptote is at y equals, and I call this the front fraction. Front fraction. So, as an example, here we go. Let's say that I have 3x squared minus x plus 100 divided by 4x squared minus 1. I'm just making stuff up. Notice right here that they're the same. 2 and 2 are the same. So the front fraction would be right here. In this particular case, I'd say 3/4. Now, if it were a way that you can reduce it down and make it look prettier, then do that. But this is your answer for that one right there. Rule number 3, I think we can squish it in here. So if the degree of the top is greater than the degree of the bottom, then there's just no horizontal asymptote. Like, as in you have to click none. Like, what's a horizontal asymptote? You click none. Okay, that's the only time you click none. Quick example, let's say I got x cubed plus 1 divided by x squared plus 1. I don't really care. Just right here, the top is bigger than the bottom, and you can't do it. Oh, wow. 1, 2, 3 examples? Wow. I wonder what they're going to be like. So, looking here, the 3 rules, they want horizontal asymptote. 3 rules, I got a 1 in the top and a 2 in the bottom. So the top is less than the bottom. Well, heck, that's rule number 1. Rule number 1 says the answer is y equals 0. Y equals 0. Y equals 0. You have to type the y equals. You have to. Otherwise, they're going to be upset. All right. Ooh, oh, here we go. Look, look. 2 and 2. This is when the top equals the bottom. Oh, so we're looking at the front fraction. Yeah, yeah. So this is rule number 2. Rule number 2. Front fraction. And that's 16 over 4. So real quick, 16 over 4. We can reduce that down to what? Just 4, right? Ta-da! Last one. 3 and 2. This is when the top is greater than the bottom. And so that's rule number 3, my favorite rule of all time. None. You just click none, and you're done. That was it. Wow. Wow. Okay. Do I have to read all this? What? Okay, that's top and bottom. I don't know. When they put P's and Q's, it just doesn't make any sense, honestly. Top and bottom. So we got one question, got another question, and then we got this word problem, which is super easy, and we're done. I think we're done, yeah. So this is not too bad, actually. So this is the 7 steps to success. 7 steps to success. Yay! Let me tell you how we're going to do it, because this is a lot of words and stuff. When have I ever used this? Honestly. You're going to look at the powers. Look at the powers for even, odd, or neither. Even, odd, or neither. Okay? Even is y-axis. Odd is origin. Odd, origin. Odd, origin. Odd, origin. Neither, neither. So there you go. When it says right here, evaluate this blah, 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 you're just going to plug in x equals 0. So that's kind of simple. X-intercepts. This is when the top is equal to 0. Solve for x. Vertical asymptotes. This is when the bottom is equal to 0. Solve for x. Horizontal asymptote is the 3 rules that we just learned. This one is make a table. But I'm going to use Desmos to kind of help us a little bit. I'll show you when we get there. It's always been a very frustrating one for me, but Desmos definitely will help. And then the last one is just graph it. Again, I probably just use Desmos. Okay, so there's all your tricks, your rules, your Chad methods. And I'm Chad. Hello. So here we go. Let's figure it all out. It says find symmetry. I'm going to write this a little bit bigger because it's kind of tiny. Look at symmetry. Look at the powers. Even, odd, or neither. Well, we got a 2. We got a 2. And this one is a 0. Even, even, even symmetry. And that is y-axis. So if they have even, you click even. If they have y-axis, you click y-axis. You didn't have to do any math. Just look at the powers. Here, I'm going to plug in 0. So I'm going to plug a 0 in wherever there's an x. Oh, that's a 4. 0 in the top. Doesn't matter. You're going to get a 0. Okay, this is when the top is equal to 0. So we got 5x squared is equal to 0. Solve for x. I'm going to start by dividing by 5. Square root both sides, I guess. And when you square root both sides, you have to do a plus and minus. But what's the square root of 0? It's 0. There's your answer. Vertical asymptotes. This is when the bottom is equal to 0. Let me just go find the bottom again. X squared minus 4. So move the 4 over. X squared is equal to 4. Square root both sides. And so we got x is equal to plus or minus 2. These are vertical asymptotes. And you have to type x equals. In fact, they might force you to do it like this. I'm not 100% sure but on the homework, but it's going to be this or that. You have to write the x equals, okay? All right, so we got 5x squared. We got x squared minus 4. Again, horizontal asymptotes, look at the 3 rules. Top and the bottom are the same. So top equals the bottom. That's rule number 2. So we're going to look at the front fraction. Notice that there's a 1 right here. So that's 5 over 1. Just 5. and it's y equals 5. Y equals 5. You have to type the y equals. Okay, whew. So that's all. It's pretty straightforward. Can Desmos help you with that? Yeah, a little bit sometimes. I wouldn't say it's perfect. Just as a quick thing, because since we're here and I have it up, I'll show you that it's really not perfect. Like here, can you find the x and y intercept at 0? Sure. Can you look at this and say symmetry? Like zoom out, do you see symmetry? Oh yeah, it's symmetric about the y-axis. So that's nice. But what are the vertical asymptotes? Like, what are these lines that you can't cross? Desmos doesn't show you very well. What about the horizontal asymptote? Where's that? Again, it doesn't really show you very well. And there's ways to find it, but it's not worth it here. Okay? So I would say a little bit of math is okay, unless it's super obvious. The table is best here in Desmos Scientific. What I'm going to do is I'm going to type the original, and then I'm going to just do x equals -4 and make sure it's fraction action. And I'm just going to go one by one and do this the whole way down. It's really convenient to do it this way. And you can see right in front of your eyes just how fast this is going for me. Going at a leisurely pace. There you go. So that wasn't too bad. You will have fractions. That's okay. Now you know what to do. Last one is the graph. I would just, it's just, you're not actually graphing it yourself. Multiple choice. And then technically there's these vertical asymptotes right here. And then there's a horizontal asymptote right there. And there you go. So we did it. Yay! You did it. Let's do it all over again. Again, graphing it first is cool. It might help a little bit. I just doubt that it's going to give you what you want every time. So I am preparing you for most everything else. Oh my gosh! No. No! This is not on your homework. This is not it. They did not teach you how to do this. I don't care about this one. I'm serious. I'm upset. I'm not doing it. Don't do it. I have other examples on my other videos. Again, here I'm just going through the workbook. There are some times that the workbook is not related. I'm sorry. You want me to do it? You want me to do it? I'll do it. I'll do it. But this is not something that's on your homework, okay? If it is, you tell me, and I'll start getting upset with somebody else, because it shouldn't be there. This is for 14-14. This is not for 13-14, okay? Whew. Looking at the graph, is there symmetry? No. So I'm going to say neither. That was an easy one. Y-intercept. Where is it crossing this Y line? It's right here. There it is, 0.5. We know that is 1/2. So there's that. X-intercepts right here and here. So -2 and 1. Nice. Vertical asymptote, that's when the bottom is equal to 0. If you look at the bottom, it's just 4. So that's really simple. Horizontal asymptote, look at the top. It's a 2 versus a 1. So this is rule number 3, our favorite, which means there's no horizontal asymptote. And if you look at the graph here, there's no horizontal asymptote indeed. But there's a slant asymptote, okay? Anyways, see, we didn't learn about slant asymptotes, and it's not in your homework, so... Okay, this problem might be on your homework, but they wouldn't... I don't know. Maybe it's not. Like, they didn't even have a table. Where's my table? Anyways, sorry. Just... Do you ever get upset with the homework, and you're like, man, this is frustrating? Me too. Me too, okay? So there's your graph. It looks something like that. Multiple choice, and we're done. Oh, okay, we got this guy. Okay, whew, done with that. I did it. I did it, didn't I? I did it. I told you I wouldn't do it, and I did it anyways. Okay, this one here, you could put it into Desmos. I don't think it's really going to help you that much, but I'm going to pick most of my stuff from the graph. And you can just look at the graph, and you can use the zoom in button to help you a little bit. So it says, what's going on after 12 minutes? 12 minutes is right here, And to me, it looks like it's at 4.7. I'm going to write 4.7. There is a range. It's like 4.7, 4.8. They would both work. Something like that, okay? So you could just look at it. You could also just go to the graph on Desmos. You could plug it in. This works almost all the time by just looking at it. It says it's lowest after how many minutes? Notice that the lowest point right here is at the 6-minute mark. So 6 minutes. And what height is it at? If you go and check it, it looks kind of like 4.3. I have never gotten it wrong when I just looked at it. Okay, normally I would say plug it into the function here. Like you can use them Desmos Scientific, but I've never gotten it wrong by just looking at it. Okay, it says what's the normal level? So like over time, what should you expect? And this horizontal line's indicating that it's going to be 6.5. So 6.5. And then they say use that to do an equation. So it's y equals 6.5. It's that equation thingy, equal sign. And then what does that mean for your mouth? It gets closer to the horizontal asymptote. And you can say that it decreases rapidly and then it increases back to 6.5. That's my choice. All right. Whew. Done. Done. Thank you very much. Have a great day.